Introduction. Students, you must have studied about closed figures. Now, what do we call the figure which is formed by three intersecting lines? A triangle, sir. Yes, you're right, Rahul. A triangle. It has three sides, three angles, and three vertices. Today, I will tell you about the congruence of triangle and the properties of triangle. Come, let's start. Objectives. At the end of this lesson, you'll be able to verify and explain whether two given figures are congruent or not, state the criteria for congruency of two triangles and apply them in solving problems, prove that angles opposite to equal sides of a triangle are equal, prove that sides opposite to equal angles of a triangle are equal, prove that if two sides of triangle are unequal, then the longer side has the greater angle opposite to it. State and verify inequalities in a triangle. Solve problems based on the above results. Congruent figures. You might have observed that leaves of different trees have different shapes, but leaves of the same tree have almost the same shape, although they may differ in size. The geometrical figures which have same shape and same size are called congruent, and the property is called congruence. Congruent objects are duplicates of one another. If two mathematical figures are congruent and you cut one figure out with a pair of scissors, it will fit perfectly on top of the other figure. Congruent. Criteria for congruence of triangles 1. We shall now learn that it is possible to prove the congruence of two triangles if we are able to know the equality of three of their corresponding parts. Consider a triangle ABC. Construct another triangle PQR such that QR is equal to BC, angle Q is equal to angle B, and PQ is equal to AB. If we trace or cut out triangle ABC and place it over triangle PQR, we will observe that one covers the other exactly. Thus, we may say they are congruent. Alternatively, we can also measure the remaining parts and observe that AC is equal to PR, angle A is equal to angle P, and angle C is equal to angle R, showing that triangle PQR is congruent to triangle ABC. This means that equality of these three corresponding parts result in congruent triangles. Thus we have Criterion 1. If any two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of the other triangle, the two triangles are congruent. This criterion is referred to as SAS, side angle side rule. Criteria for congruence of triangles 2. The next criteria for the congruence of the triangles is that if any two angles and a side of one triangle are equal to corresponding angles and the side of the other triangle, then the two triangles are congruent. This criterion is referred to as ASA, angle side angle, or AAS, angle angle side rule. Let's solve an example now. In figure, PX and QY are perpendicular to PQ and PX, which is equal to QY. Show that AX is equal to AY. Solution. In triangle PAX and triangle QAY, angle XPA is equal to angle YQA because each is 90 degrees. Angle PAX is equal to angle QAY because these are vertically opposite angles, and PX is equal to QY. Therefore, by AAS congruence rule, triangle PAX is congruent to triangle QAY. Therefore, AX is equal to AY, CPCT. Some properties of a triangle. Theorem. The angles opposite to equal sides of a triangle are equal. Let's prove it. Given is a triangle ABC in which AB is equal to AC. We have to prove that angle B is equal to angle C. Construction. Draw bisector of angle BAC meeting BC at D. Proof. In triangle ABD and triangle ACD, AB is equal to AC is given. Angle BAD is equal to angle CAD by construction, and AD is equal to AD common. Therefore, by SAS rule, triangle ABD is congruent to triangle ACD. Hence, angle B is equal to angle C. The converse of the above theorem is also true, which says that the sides opposite to equal angles of a triangle are equal. Example: prove that the three angles of an equilateral triangle are equal. Given an equilateral triangle ABC, we have to prove that angle A is equal to angle B, which equals angle C. Proof: AB is equal to AC is given. Therefore, angle C is equal to angle B because angles opposite equal sides are equal. Mark it as 1. Also, AC is equal to BC is given. Therefore, angle B is equal to angle A. Mark it as 2. From 1 and 2, angle A is equal to angle B, which is equal to angle C. Hence, the result: ABC is an isosceles triangle in which AB is equal to AC. If BD is perpendicular on AC and CE is perpendicular on AB, prove that BD is equal to CE. Solution: in triangle BDC and triangle CEB, angle BDC is equal to angle CEB because each angle is 90 degrees. Angle DCB is equal to angle EBC because angles opposite equal sides of a triangle are equal, and BC is equal to CB because they are common. Therefore, triangle BDC is congruent to triangle CEB AAS. Hence, BD is equal to CE. This example gives us a result which says that perpendiculars drawn to equal sides from opposite vertices or altitudes of an isosceles triangle are equal. Criteria for congruence of triangles 3. In order to explore another criterion, we again take a triangle ABC. Now take 3 thin sticks equal in lengths to sides AB, BC and CA of triangle ABC. Place them in any order to form triangle PQR near the triangle ABC. By measuring the corresponding angles, we find that angle P is equal to angle A, angle Q is equal to angle B, angle R is equal to angle C, establishing that triangle PQR is congruent to triangle ABC. This means that equality of the 3 corresponding sides of 2 triangles results in congruent triangles. Thus, we have criterion 3. If the 3 sides of one triangle are equal to the 3 corresponding sides of the other triangle, then the 2 triangles are congruent. This is referred to as SSS, side-side-side congruence rule. Criteria for congruence of triangles 4. Now construct 2 right-angled triangles with hypotenuse equal to 7 cm and one side equal to 5 cm each. Cut them out and place one triangle over the other with equal side placed on each other. We will observe that the 2 triangles cover each other completely, and so they are congruent. Or we can say that 2 right triangles are congruent if one pair of sides and the hypotenuse are equal. This we have criterion 4. If the hypotenuse and the side of one triangle are respectively equal to the hypotenuse and the side of the other triangle, then 2 right triangles are congruent. This criterion is referred to as RHS, right angle hypotenuse side. Inequalities in a triangle 1. We have learnt the relationship between sides and angles of a triangle when they are equal. We shall now study some relations among sides and angles of a triangle when they are unequal. Theorem: if 2 sides of a triangle are unequal, then the longer side has the greater angle opposite to it. Let's prove it. Given is a triangle ABC in which AB is greater than AC. We have to prove that angle ACB is greater than angle ABC. Construction: mark a point D on the side AB such that AD is equal to AC and join DC. Proof. In triangle ADC, AD is equal to AC. Therefore, angle ACD is equal to angle ADC because angles opposite equal sides of a triangle are equal. But angle ADC is greater than angle ABC because exterior angle is greater than opposite interior angles. Again, angle ACB is greater than angle ACD because point D lies in the interior of the angle ACB. Therefore, angle ACB is greater than angle ABC. The converse of this theorem is also true, which states that in any triangle, the side opposite to the larger, greater angle is longer. Inequalities in a triangle 2. You have already learned the relationship among the three angles of a triangle, that is, the sum of the three angles of a triangle is 180 degrees. We shall now study whether the three sides of a triangle are related in some way. Draw a triangle ABC. Measure its three sides AB, BC and CA. We observe that 1. AB plus BC is greater than CA. 2. BC plus CA is greater than AB. And 3. CA plus AB is greater than BC. Thus, we conclude that the sum of any two sides of a triangle is greater than the third side. Example. In figure, AD is a median of triangle ABC. Prove that AB plus AC is greater than 2AD. Solution. Reduce AD to E such that AD is equal to DE and join C to E. Consider triangle ABD and triangle ECD. Here BD is equal to CD. Angle ADB is equal to angle EDC. AD is equal to ED. Therefore, by SAS congruence rule, triangle ABD is congruent to triangle ECD. Therefore, AB is equal to EC, CPCT. Now, in triangle ACE, EC plus AC is greater than AE, or AB plus AC is greater than 2AD, because AD is equal to ED, which implies that AE is equal to 2AD. Did you know?
We all must have seen the ice tray in your refrigerator. Observe that the molds for making ice are all congruent. The cast used for molding in the tray also has congruent depressions. Maybe all are rectangular, or all circular, or all triangular. So, whenever identical objects have to be produced, the concept of congruence is used in making the cast.
Summary. Let us summarize what we have learned. Figures which have the same shape and same size are called congruent figures. To prove that two triangles are congruent, we need to know the equality of only three corresponding parts. These corresponding parts must satisfy one of the four criteria. 1. SAS. 2. ASA or AAS.